Then next one more method, suspend and resume methods. Next program is suspend and resume methods. The suspend and resume methods are used to pause and restart the execution of a thread. You know about already, to pause. Sometimes it's going to be suspended. After that, it's going to be joined. The syntax for suspend method is final void suspend. Final void suspend. The syntax for resume is final void resume. Now see the program. Class A extends thread, public void run try for int I equal to 1, I less than or equal to I plus plus sleep 1000. So already sleep is over. Sometime it's going to be 1000 nanoseconds, it's going to be sleep. After that, wake up and it's going to be run. Then next, class B extends thread, again B also going to be sleep sometime and it's going to be run. Similarly, class suspend, only two I am taking. One is nothing but sleep is over. Now what is second one? Sleep is over. Okay, leave it. Sleep is over. But after start also it's going to be sleep. After start also it's going to be sleep. See here, A1 equal to new A, B1 equal to new B, 2 only. A1 dot start, B1 dot start. After starting, then try thread dot sleep 1000, A1 dot suspend. So thread dot sleep 1000 nanoseconds is going to be sleep. So at the time A1 dot suspend, A1 dot suspend, A1 is going to be suspended. So A1 is suspended. What is going to print? System dot out dot println suspending thread A is going to print it. Similarly, thread dot sleep 2000, then A1 dot resume. That means after sleeping of 2000, okay, A1 is started about the resume. So what it going to print? System dot out dot println resuming thread A. Similarly, next one, thread dot sleep 1000, B1 dot suspend. That is system dot out dot println suspending thread B. Again thread dot sleep 2000, B1 dot resume. After 2000 nanoseconds, B1 is going to be resume. So at that time, what is going to print? System dot out dot println resuming thread B. Resuming thread B. That means after 1000 nanoseconds, it's going to be suspended. After 2000 nanoseconds, it's going to be resumed. After 1000 nanoseconds, B1 is going to be suspended. After 2000 nanoseconds, it's going to be resumed. Okay, so this is nothing but this is catch interrupted exception system dot out dot println e. Now see here. So thread resume we are written, but at the same time what you have tried about the join. Once it is suspended, yeah, that it should be joined. So that means try A1 dot join, B1 dot join, both are going to be joined. Both are going to be joined. Okay. So up to this, that is total 14 pages, that is 7 papers about the material. In these 7 papers, 10 pages are over. That is 5 papers are over. Only variation is in 2 papers. Variation is only in 2 papers, which is going to complete about the multi-threading. See the importance, see the easiness. Okay. Now we see thread synchronization. From this program going to be changed, remember. Thread synchronization. What is meant by synchronization? When two or more threads need to access a shared resource, the resource will be used only one thread at a time. Suppose there are two threads want to a resource, When there are two threads want to a shared resource, okay, or two or more threads are there, it wants about a shared resource. At that time, one can use that resource at a time. At a time, one can use that one. Okay, that is called synchronization. That means there is a shared resource is there. Thread A, thread B, thread C. These are going to be waiting for the shared resource. For example, I am telling there is a shared resource some X, shared resource some X, that X want to use multi-threads, 3 threads, thread A, thread B, thread C. Then that shared resource X, first it going to be used by thread A. After completion, it going to be used about thread B. After completion, it going to be used about thread C. Suppose if there is no synchronization, then what happened? This thread A, thread B, thread C going to be fight. What it going to fight? I want first. Thread A says that I want first the shared resource. Thread B says that I want that shared resource. Thread C says that I want that shared resource. but the shared resource cannot use any nobody. You understood about the point? This shared resource is there. Thread A, thread B, thread C is there. Shared resource should be used by thread A, thread B, thread C. Okay. Now, if there is no synchronization, what is meant synchronization? First, thread A can complete using about shared resource. Then thread B going to be start using about that shared resource. Then next thread C can start using about that shared resource. That is called synchronization. That is one complete about its use, second will start about its use. Second completed, third can use about that resource. Okay, use about that resource. Then that is called as a synchronization. If there is no synchronization, what happened? Thread A says that I want to use that shared resource. Thread B says that I want to use that shared resource. Thread C says that I want to use that shared resource, but nobody can use it. In that situation, it is called as a deadlock. In that situation, it is called as a deadlock. So, whenever there is a shared resource is there, the shared resources want to use about the number of threads, then there should be a synchronization. Then only one can use that one at a time. Otherwise, what happened? Deadlock situation going to be occur. Then when deadlock situation going to occur, nobody can use about that shared resource. Example. For example, one thread may try to read a record from a file while another is still writing to the same file. Depending on the situation, we may get the bad results. Yes or no? For example, one thread may try to read a record from a file, another is still writing to the same file. Suppose after completely writing that file, then the other person can start reading. That is called as synchronization. That is called as a synchronization. If it is not doing like that, is still writing, reading, still writing, okay, continuously reading. Then what happened? He cannot complete it, but he start about the reading. Then he going to miss lot of the things. Yes or no? Okay, so depending upon the bad situation, depending upon the situation, bad results we get. To overcome this problem, Java use synchronization. In synchronization, first one thread finish writing the file. Then next other thread start reading that file. Then no problem will occur. Till one thread finish writing, other thread has to wait. This is called as a synchronization. Now see here class A. See, same code I have written here, just added one word synchronized. Added one word synchronized. Public void run, instead of public void run, I have written about the void display. That's all. Remaining is same. See here, class A, synchronized void display, try thread.sleep 1000, system.out.println hello, catch exception is system.out.println. Up to this, it is common. Now, class B implements runnable. Class B implements runnable. Here I am taking A object is A1 and thread is T1. So A object is A1, I am taking thread is T1, and in class B I am taking about same A1. So here A1 is there already reference. Here A1 is there already reference. That's why I written this dot A1 equal to A1. Then thread T1 is there here. T1 equal to new thread. This I written. Then T1 dot start. Public void run A1 dot display. That's all about the simple program for synchronization. That means what is the meaning of this one? Here synchronized void display means the display can be the display can be for one object it going to be display, and it will take some time. For second object is going to display, then after some time it going to be display for third object. That is the meaning of this one. Okay, so this display is going to be synchronized. Means once one completed about its display, it can start for second one display. Then second one is completed about the display, then start about the third one for display. So in this case, here try thread.sleep 1000, system.out.println hello. Then what is here? Catch exception is system.out.println. Now class B implements runnable. Here object is taken first, thread T1 is taken first. Then B A1. That means I am taken about the constructor parameters A1. This dot A1 equal to A1. Then start about this thread T1 equal new thread this. Then T1 dot start. Then A1 dot display should call in the public void run, because this display is going to be synchronized. Then in execution, A1 equal to new A, object is created. Then B1 equal to new B A1, B2 equal to new B A1, B3 equal to new B A1. So these three A1s going to be called in BB1, BB2, BB3. First BB1 completion, then start about for BB2. Then after BB2 completion, start for BB3. Then communication between threads or inter-thread communication. This program also different. But approximately concept and code will be simple only, remember. Communication between threads, or it is also called inter-thread communication. Polling. Polling means wasting CPU time. So the communication between two or more threads is called inter-thread communication. What is inter-thread communication? The polling means wasting CPU time is called polling, remember. The communication between two or more threads is called inter-thread communication. In inter-thread communication, polling is avoided. That is, CPU waiting time will be avoided. For example, there is thread A, thread B, thread C. CPU is waiting for execution of thread A, but thread A is not completed. Immediately start for going for thread B. Okay, after completion of not after completion, after 50% or 25% completion of thread B can come to the thread A, like that. That means CPU always busy, okay, always busy, and it cannot going to waste a single nanosecond. That is called as a inter-process communication. In inter-process communication, the CPU cannot going to waste its time, waste its time. Okay. Normally, what happened means if A is there, B is there, C is there. If suppose if CPU want to execute A, up to its completion, CPU should wait. Okay. So then it goes to the B. If after completion after completion of B only, it start about execution of B. Then how much time it should wait? Suppose for A it is waiting for 5 seconds. Then for B again 10 seconds it should wait. For C again 10 seconds. How much is going to wasted? 10 plus 10 plus 5, 25 seconds is going to wasted. Suppose for A 5 seconds is going to wasted. No. So in that 5 seconds, if it starts execution of the B, then that 5 seconds will be covered. No need to wait. That means fully engaged about the CPU process. CPU process fully engaged, so that there is no waiting time of CPU. Always busy, so that it will execute all the things at a time or minimum time. Okay, minimum time it going to execute all the things. Otherwise, if CPU is waiting means the execution time will be increases. So the communication between two or more threads is called inter-thread communication. Inter-thread communication, polling is avoided. For example, consider producer and consumer problem, where producer is producing some data and consumer is consuming it. If the producer has to wait until the consumer is finished, in that case it starts polling. Yes or no? If the producer has to wait until the consumer is finished, okay, producer has to wait until the consumer is finished. In that case, it starts polling because the consumer wastes the CPU time. Similarly, if the consumer has to wait until the producer is produced, in that case, start polling. That is, the producer wastes CPU time. To avoid this, Java use inter-process communication by using the wait, notify all methods. Now see the program producer consumer problem. See here producer, very simple, synchronized get method. I am using about the get method. Initially B is taken as a false, that is not B. Try wait and catch system.out.println is over, then got plus n. Now B equal to false. B is false only, then notify. After some time it going to be notified. So wait means it should write in the try and catch. Then got plus 1 you write. Then B equal to false and notify. Similarly for put, this get for put again wait, but in this time B equal to true. Okay, and notify. Same thing. Now producer implements runnable and consumer implements runnable. In producer implements runnable, previously you are written in synchronization AA1 thread T1. Producer AA1 this dot A1 equal to A1 same thing. This the T1 equal new thread this same thing. T1 dot start also same thing. But in public void run here you have to write about the for int I equal to 1 I less than equal to I plus A1 dot put I. Similarly consumer side. Consumer side again same thing. AA1 thread T1 consumer same thing. This dot A1 equal to A1. So maximum I going to be used about the same code, remember. Maximum whatever the code is going to be repeatable, that much code I going to be used in the program. That is the most advantage. So that you are not going to be have any confusion to write about the coding, to write about the this one. Okay, that is the most important. So public void run for int j equal to 1. Here you write a1 dot get it. One is put it, one is get it. Okay, that means once one put is completed, then get it. So after second is put is completed, then get it. After put third case is completed, it get it. Like that it going to be synchronized. Finally you write about the AA1 equal to new public void main, AA1 equal to new A, producer P1 equal to new producer A1, consumer C1 equal to new consumer A1. Now next one is nothing but reading data from files and writing data to files. This is one more program, one more concept, that is nothing but reading data from files and writing data to files. Write data to files. To write data to files we use the classes file writer and buffered reader. The next line method read text from keyboard and write method write text to file. The new line brings the cursor to the next line. Read data from files. To read data from files we use the classes. Here we use the file reader and buffered reader. Here read line method read the text from file. The example program specifies write data to file and read data from file. Write data to file. Write data to file how you see. Import java.io.star. That is nothing but the input output import statement, then util statement. Public class write add demo. Here string null s1 null. Now scanner used to read text from keyboard, use about the scanner. System.out.println enter text into file ending with star. Then file writer. So I mean writing text now. So enter text means writing text. That's why I'm writing about the file writer fw equal to new file writer file1.txt. So in file1.txt I want to write it. So for that to write continuously infinitely buffered writer use about the buffered writer. Then for infinite loop semicolon is infinite loop. S1 equal to next line. So get it from next line. Suppose if you write the star, then it's going to break it. If you not write about the star, it's going to write the data. Again, it goes to the new line. Again, it's going to read the new line, next line, and print. That means whatever you're going to be type it, it's going to be write it in the file. So once you put it, you click about the star, it comes to the end. Now bw.close. Similarly, reading. File reader fr equal to new file reader file1.txt. The contents of file are given by, now write buffered reader br equal to new buffered reader, while l equal to br dot read line is not equal to null. So it's going to read it and system dot println l means it's going to print the text. So here you write the text, here you read the text. Okay, just like about your C. In also C also there is the programs are there how to write the text in files, how to read the how to write the text in files, how to read the text from files. The example program specifies read data from given file and print data to screen. Just read data from given file without writing file, just read data and print. Then import java.io.star, import java.util.star, public class read demo, public stat void means same code, string l equal to s1 equal to same thing, scanner s also same thing. Just you write enter a file name. That is only the vary. S1 equal to s dot next line over. Now file reader. This one is same thing about the top. That is file reader fr equal to new file reader, buffered reader br equal to new buffered reader. Then while l equal to br dot read line is not equal to null, system.out.println l. Automatically it going to be read the data from that file, and it going to write the data. So read means here file reader going to be read the data, and s1 equal to s dot next line means it going to be read. S1 is going to be read in file reader, then buffered reader, and then read line, and it's going to print. Okay, so file reader and buffer reader, both it can read about the text and also write into the text. br.close catch exception e system.out.println e. Now what is meant by the random access file? Last topic. Reading and writing using the file input and output streams are a sequential process. Reading and writing using the file input and output streams are a sequential process, but using a random access file, we can read or write at any position within a file, at any position. An object of the random access file class can do the random file access. We can read and write bytes and all primitive types values to a file. The example program specifies write data to file and read data randomly from file. See same program here, import java.io.star, import java.util.star. Public class random demo 1. Public static void main, string L equal to null, S1 equal to null. Scanner S equal to new scanner system.in. System.out.println, enter text into file ending with exit. So random access file equal to new random access file, file1.txt, read and write RW. raf.seek. So you have to use about the raf.seek, that is random access file. Raf means random access file. For infinite s1 equal to s dot next line, s1 dot equal exit then break, or s1 dot equal star. If instead of exit, if you write the star, then it's going to break it. Then raf dot write bytes. So you're going to be write the text. Writing text is over. Now reading. So system dot in output dot println, the contents of the file are given by raf dot seek 0. So from 0 means from starting 0 you can write, starting 0 you can read. Sometimes you can 10 or 20 means after 10 bytes you can read, write, after 10 bytes you can read, like that also you can write by giving 0 and by giving 10, like that. rf.readline is not equal to null, system.out.println L, it's going to print. Now system.out.println, the length of the file is also you can write. Okay, the length of the file also you can write, and also you can write about the text also you can write. Catch exception e system.out.println e. The example program specifies read data from given file randomly and prints data to the screen. Import java.io, java.util, random demo 2, up to this is common. Try scanner s equal new scanner system.in. Then system.out.println, enter a file name. Now you read about this file name. By using file f, it's going to read it. Now by using random access file, while read that one and print that one. That means by writing the file name also, you can read and display the contents. Display the contents. Okay. So this completes about the multi-threading. This completes about the multi-threading unit.